So we have one more theorem in this section. It's called Descartes' rule of signs. It's named after a French mathematician. I don't know about the spelling of Descartes. I wouldn't spell it that way, but that's the way the book does, so I went with it. Descartes' rule of sign gives us a little bit more information about real zeros and non-real zeros. Okay, so we usually look for how many real zeros there are. So say you have a function. I'll just make a simple one here. That's a 3x there. Okay, so say that's your function. Well, if you want to know how many possible positive real zeros. So not imaginary ones, but real. Doesn't say anything about rational. It's just if they're real or not. Okay, so possible positive real zeros. You count the sign changes. The function has to be in standard form. We'll see how this is positive, but then this is negative, and then this one's positive, and this one's positive. So you're looking at the coefficients. So a positive to a negative, that's a sign change. A negative to a positive, that's a sign change. But positive to a positive, that's not a sign change. Okay, so that's what we're talking about, the signs changing. So how many sign changes were there? There were a total of 2, 1 plus 1 being 2. So that's how many possible positive real zeros there are. There are either 2, and then here comes the tricky part maybe, or there are none. So it always counts down by 2s. So if you had 1 possible positive real zero, then you know you have one because you can't count down by 2s. There can't be a negative number, right? So it could be, but if there were 2, it could be 2 or it could be 0. All right. Now, you'll see it when we do the example. Possible negative real zeros. So what you do is you have to find f of negative x. So you're putting a negative x into the function, and then you're going to count the sign changes. So this, if it has an odd exponent, it's going to change its sign. But if it's even, then it's not going to change its sign. Because when you square a negative x, you're just going to have x squared. So, but this one, see, it's going to be a negative 3x because it's x to the first power, negative x to the first power plus 7. Okay, now we count the sign changes. So it's going from negative to negative, no change. Negative to negative, no change. Negative to positive, 1. So we know there is 1 negative real zero. Now, how does this help us? Well, remember we were trying all those zeros, those rational zeros, and we're saying, well, which one is it going to be? Well, if we know there's only 1 negative one, and there has to be a negative real zero, it might be rational, it might not be, but you could try the positive or the negative possibilities and see if one of them worked. There's not a guarantee, but you could try it. Okay. And here you know if there are 2, possible positive real zeros. So say you're doing synthetic division and you find 1 positive one, well, then you know there's another positive real zero. Again, it might not be rational, but at least you know that there's another positive one. Okay. So determine the possible number of positive and negative real zeros for, and then they give us a function. So we're looking at the sign changes here. So let me write possible, positive. So we'll do that first. So count the sign changes. Positive to positive, no change. Positive to positive, no change. Positive to positive, no change. That means there are no positive real zeros. So you don't even have to try. Like if you had that long list of plus or minus 1, plus or minus 2, plus or minus 4, you don't even try any positive ones because none of them are going to work. There are no positive real zeros. Okay? All right, so a real zero doesn't have to be rational, but a rational zero does have to be real. Okay, remember these are possible rationals. Well, if you're not going to have any positive reals, then you can't have any positive rationals either. Okay. I hope that makes sense. You can think about it for a while. All right, now we have to do the negatives. So you have to find f of negative x. So think about putting a negative x in. And then you're going to simplify that. Now you're going to count the sign changes. So negative to positive, change. Positive to negative, change. Negative to positive, change. Okay, so the negative, possible negative, and I should put real zeros. Forgot to put that up above. Real zeros. Put a line to separate it. So how many possible negative real zeros are there? Well, there's three sign changes. So 1 plus 1 plus 1 is 3. So there's either 3 or 1. Okay? So again, you could try the negative ones and see, see what works. Okay. That's it.